Today let us learn the concepts of kinematics. What is the concept of point mass? An object is said to be a point object or a point mass when the change in its position is very large as compared to its own size. For example, a person standing on a platform is regarded as a point object for the train passing through the platform. Earth is considered as a point object since for the motion around the sun, the size of Earth is very small as compared to the distance between sun and Earth. What is motion and rest? An object is said to be in motion if its position changes with respect to its surroundings in a given time. If the position of an object does not change with respect to its surroundings, it is said to be at rest. The motion is said to be a one-dimensional motion when one of the three coordinates specifying the position of an object changes with time. If the motion is a two-dimensional motion, two of the three coordinates specifying the position of an object change with the time. If it is three-dimensional motion, all the three coordinates will be specifying the position of object with change in time. Distance and displacement. The length of the actual path covered by an object in a time interval is called distance, while the difference between final and initial positions of an object is called displacement. Distance is a scalar quantity which has only magnitude. Displacement is a vector quantity which has both magnitude and direction. Speed. The distance traveled by an object in an unit interval of time is called speed of the object. The displacement of an object in unit interval of time is called velocity of the object. Speed equals to distance by time, velocity equals to displacement by time. Suppose an object is moving along a straight line. Suppose with respect to some reference point, its position is S1 at time t1. S1 at time t1 and becomes S2 at time t2. It means in the time interval t2 to t1, the displacement of the object is s2 minus s1. Hence, average velocity during his time interval would be average velocity. I am writing at v bar, that is equal to s2 minus s1 by t2 minus t1. Acceleration. Rate of change of velocity is called acceleration. It can be represented by v2 minus v1 by t2 minus t1. Slope of displacement time graph gives us velocity. So velocity is equals to displacement by time. So in this case, we have displacement time graph and it is a straight line passing through the origin. Here, slope is constant at every point of time. Here the slope, if it is 3 theta, here also it is theta. So its velocity is constant. Slope is nothing but tan theta. Here also theta is the same as this one. So there is same slope. So there is same tan theta. So we can say velocity is constant. Let us see this case. In this case, we are going to compare the slopes of A and B. The slope of this is also the same slope of displacement and time. Slope of A we can see if it is theta 1 and slope of B if it is theta 2. Theta 1 greater than theta 2. So that tan theta 1 should be greater than tan theta 2. And tan theta is directly proportional to slope and that is directly proportional to velocity. If tan theta 1 is greater than tan theta 2, then velocity 1. Velocity of A is greater than velocity of B. Let us see this case. Here again we are going to have the same graph. In this case we can see slope is 0. Tan theta is tan 0. Theta is 0. Tan 0 is 0. Here slope is 0. What we can conclude? the time, if even if the time is increasing, t equals to 1 second, 2 second, 3 second, 4 second and so on, its position is not changing. It is, if it is 4 meter, then it is same, the 4 meter is continuing all the time. So we can say there is zero velocity. Let us understand this graph. Initially the man is standing at 20th meter, then he is coming, as the time passes, then that he is coming to 0 meters. At 10th second he is at 0 meters. So we can imagine it like this. He is standing at 20th meter when time t equals to 0 second, and as the time passes, when it's 10 seconds, he came to 0 meter. So t1 equals to 0 second, t2 equals to 10 seconds. S1, initially he was at 20 meters, so 20, S2 is 0. Finally he came to 0 meters. Average velocity is S2 minus S1 by T2 minus T1. 0 is S2 because finally he came to 0 meter, and S1 is, initially he was at 20, T2 is 10 and T1 is 0. So we are getting minus 2 meter per second. Here we can observe theta is greater than 90 degree, tan theta is negative. So velocity is negative. So we can conclude, if velocity is negative, from this imagination we can say he is returning to the reference point, he is returning to 0 meter. Or if the velocity is negative, then he is moving this way, that is, he is moving in the negative direction or negative velocity, returning to the reference point. Okay, now let us see this graph. So here, initially when time equals to 0 second, he is at 0 meter, and when time t equals to 2 seconds, he is at 3 meters. So he has started from 0 meter and then he has reached 3 meter in 2 seconds with some velocity, because here it is theta 1, here it is theta 2. If slopes are different, then here he was using one velocity, and here he is using different velocity. Then from 3 meters to 5 meters, from 3 meters to 5 meters, he is using a different velocity. Then he has reached the 5 meters. From 6 to 12 seconds, his displacement is not changing. He is remaining in the fifth meter for 6 to 12 seconds. That is, theta is equals to 0 for 6 to 12 seconds. If theta equals to 0, then we can say tan theta equals to 0 and velocity equals to 0. From 6 to 12 seconds, his velocity was 0. Then from 12 seconds to 14 seconds, we can see his displacement was from 5, it's reducing from 5 meter to 0 meter. That is, he is returning back to the normal, the reference point. So from 5 meters, so he is returning to 0 meter in the time interval, this time interval 14 minus 12, 2 seconds. So what is the average velocity for C to D? S2 minus S1 by T2 minus T1. S2 is 0 because we are considering this interval C to D. S2 is 0 because he has finally reached 0 meters, and S1 initially he was at for 5 meters. 5 by T2 is 14 seconds and T1 is 12 seconds. So we are getting minus 2.5 meter per second is the average velocity. Here also we are using a minus, so from this we can easily conclude that he is returning to the normal position. Also from the graph we can say he is reducing from 5 meters to 0 meter, but the time is going on increasing. So this is the average velocity, and if we are getting negative, then we can say he is returning to the reference point in this way.